So, here's something worth thinking about as you settle in tonight. Right now, as you're lying there, your brain is doing something on the order of 100 trillion operations, not per hour, not per minute, per second. And the vast majority of those operations, we're talking 95% or more, are happening completely outside your awareness. You have no idea they're occurring. You didn't ask for them. You can't watch them happen. And yet they're running your life in ways that would genuinely astonish you if you could somehow peek behind the curtain. That's what we're going to talk about tonight. The subconscious mind, that enormous, quiet engine humming beneath the surface of everything you think and feel and do. And I want to take it slow, because this is one of those subjects where the deeper you go, the more fascinating it gets, and also the more confusing it can be if someone rushes through it. So we're not going to rush. We're going to wander through this together, starting from the very beginning, from the first time anyone even suspected that there was more going on inside a human mind than what a person could consciously report. And that beginning takes us to a surprisingly specific place. It takes us to Germany in the late 1600s and early 1700s, to a philosopher and mathematician named Gottfried Wilhelm Leibniz. Now, you probably know Leibniz, if you know him at all, as one of the inventors of calculus. He and Newton had that famous, bitter priority dispute that dragged on for decades. But Leibniz was thinking about far more than mathematics. He was thinking about perception, about what the mind does when you're not paying attention to it. And he came up with this idea that he called petite perceptions, little perceptions. Tiny mental events that are too small or too faint for you to consciously notice, but that nonetheless shape your experience. His favorite example was the sound of the ocean. Think about standing on a beach, listening to the roar of waves. That roar, Leibniz argued, is actually made up of millions of individual tiny sounds. The crash of each individual droplet of water, each tiny collision of water against sand. You can't hear any single one of those sounds individually. They're below the threshold of your awareness. But added together, they create the roar. So your mind must be processing those individual sounds somewhere, somehow, even though you never become conscious of any one of them. That's a remarkably modern insight for a guy writing in the early 1700s. And it's the first real crack in what had been a pretty solid assumption in Western philosophy up to that point. The assumption that the mind and consciousness were basically the same thing. That if something was happening in your mind, you knew about it, by definition. Descartes, just a generation before Leibniz, had essentially built his entire philosophy on this idea. I think, therefore I am. The one thing you can't doubt is your own conscious experience. And implicit in that is the notion that your mind is transparent to itself, that you have complete access to everything happening inside it. Leibniz quietly said, "No, actually, you don't. There are things happening in your mind that you have no access to whatsoever." And that idea, that simple, radical idea, is really the seed from which everything we're going to talk about tonight eventually grew. But here's the thing. After Leibniz planted that seed, it took a surprisingly long time for anyone to really water it. For most of the 1700s, philosophy, and what we'd now call psychology, were still dominated by the idea that the mind was basically a conscious workspace. The British empiricists, Locke, Hume, Berkeley, they were interested in how experience builds knowledge, how sensations become ideas, but they were mostly talking about conscious experience. The stuff you can introspect on, the stuff you can report. It wasn't until the late 1700s and early 1800s that things started to shift again, and the person who really pushed things forward was another German philosopher. His name was Johann Friedrich Herbart, and he's one of those figures who's been almost completely forgotten by most people, but who was enormously influential in his own time. Herbert was doing something genuinely new. He was trying to create a mathematical model of the mind, a scientific psychology, decades before anyone else was seriously attempting that. And here's what Herbart proposed that matters for our story. He argued that ideas, mental representations, thoughts, exist in a kind of competition with each other. They push against each other. They have different strengths, and when an idea is strong enough, it rises above what he called the threshold of consciousness, and you become aware of it. But when it's too weak, or when it's being suppressed by stronger, incompatible ideas, it sinks below that threshold. It doesn't disappear. It's still there, still exerting force, still influencing other ideas, but you can't see it anymore. It's become, in Herbert's language, unconscious. Now, think about what that means. Herbert is saying that your conscious mind, the stream of thoughts and feelings you're aware of right now, is just the tip of something much larger. It's just the ideas that happened to win the competition at this particular moment. Below the surface, there's this whole churning mass of ideas that lost, ideas that were pushed down, ideas that are waiting for their chance to rise back up. And those submerged ideas are still active. They're still doing things. They're still shaping the ideas that are above the threshold. That's a remarkably sophisticated model for the early 1800s, and it directly influenced someone you've definitely heard of, Sigmund Freud. But we'll get to Freud. We'll spend real time with Freud, because you can't talk about the subconscious mind without talking about Freud, even though a lot of what he said turned out to be wrong, or at least unprovable. But his influence on how we think about the hidden parts of our minds is so enormous that we need to take him seriously and carefully, and we will. Just not yet. Because before Freud, there's another thread of this story that I think is even more interesting, and it starts with a question that sounds almost absurdly simple. How fast do you think? In 1850, a German physiologist named Hermann von Helmholtz, and yes, a lot of this early story happens in Germany. The Germans were really dominating the science of the mind in this era. Helmholtz did something that many scientists of his time thought was literally impossible. He measured the speed of a nerve impulse. He took a frog's leg, stimulated the nerve at different points along its length, and timed how long it took for the muscle to twitch. And he found that the signal traveled at about 27 meters per second, which sounds fast, but is actually shockingly slow compared to, say, the speed of electricity in a wire, which is close to the speed of light. A nerve impulse is millions of times slower than an electrical signal in a copper wire. And here's why that matters for our story about the subconscious. Before Helmholtz's experiment, a lot of people assumed that nerve transmission was basically instantaneous, that when you decided to move your hand, the signal got there at something like the speed of thought, whatever that meant. It was assumed to be immeasurably fast. And if it's immeasurably fast, then there's no gap between your conscious intention and your action. You think it happens, end of story. But Helmholtz showed there's a measurable delay. There's a gap, and in that gap, things are happening that you're not aware of. Your nervous system is doing work, real, physical, time-consuming work that falls outside your conscious experience. You decide to pick up a cup, and between that decision and the actual movement, there's a flurry of unconscious neural activity that takes real, measurable time. Helmholtz went further. He studied perception, particularly vision and hearing, and he realized that what you consciously see is not a raw feed from your eyes. It's a construction. Your brain takes incomplete, ambiguous, sometimes contradictory information from your senses and builds a coherent picture from it. And it does this unconsciously. He called these unconscious inferences, Your brain is making logical deductions about what's out there in the world, filling in gaps, correcting errors, making assumptions, and it's doing all of this below the level of your awareness. By the time the finished product reaches your consciousness, it feels seamless. It feels like you're just seeing the world as it is. But you're not. You're seeing a model that your subconscious mind constructed for you. Think about that for a second. Every single visual experience you've ever had, every sunset, every face, every word on a page, was assembled by processes you have zero conscious access to. You've never once seen the raw data. You've only ever seen the finished interpretation. And that interpretation involves assumptions, shortcuts, and educated guesses that your subconscious makes millions of times per second. This is why optical illusions work, by the way. An optical illusion isn't your eyes malfunctioning. It's your subconscious inference engine being tricked. The unconscious processes that normally do an excellent job of interpreting visual data are being fed something that exploits their assumptions, and the result is a conscious experience that doesn't match reality. You see something that isn't there, or you don't see something that is. And the really unsettling part is that even when you know it's an illusion, you usually can't make yourself stop seeing it. Because the process that creates the illusion is unconscious. Your conscious knowledge can't override it. You're watching your own subconscious mind refuse to listen to you. So by the middle of the 1800s, we've already got this picture emerging, and it's emerging from multiple directions at once, from philosophy, from physiology, from early experimental psychology. The picture is that consciousness is not the whole mind. It might not even be most of the mind. It might be more like a small, well-lit room in a very large, very dark house. And most of what the mind does, most of the processing, most of the decision-making, most of the heavy lifting, happens in the dark parts of that house. In rooms you can't enter. Behind doors you can't open. And this is where things start to get really interesting, because right around this same period, in the 1870s and 1880s, something was happening in the clinics and hospitals of Europe that would blow this whole question wide open. Doctors were encountering patients whose symptoms made no medical sense, people who were paralyzed in one arm but had no nerve damage, people who were blind but whose eyes were perfectly healthy, people who had seizures with no neurological cause, and the treatment that seemed to work for these patients, at least sometimes, was one of the strangest and most controversial practices in the history of medicine. It was hypnosis, and the story of how hypnosis collided with the emerging science of the unconscious mind, and how that collision eventually led a young Viennese neurologist named Sigmund Freud to develop the most famous and most debated model of the subconscious ever created. That story starts in a hospital in Paris in the winter of 1885 with a showman physician named Jean-Martin Charcot, who had a flair for the dramatic and a ward full of patients whose suffering was about to change everything we thought we knew about the mind. Charcot was a remarkable figure. By the time that young Viennese neurologist showed up at his door, Charcot was already one of the most famous doctors in Europe. He ran the Salpêtrière Hospital in Paris, and hospital is maybe a generous word for what the Salpêtrière was. It was enormous, more like a small city, really. Originally built as a gunpowder factory, then converted into a kind of asylum and poorhouse for women. By Charcot's time, it housed thousands of patients, women with epilepsy, with dementia, with all manner of neurological conditions. And Charcot had made his name By carefully studying these patients, classifying their symptoms, mapping the progression of diseases like multiple sclerosis and ALS, he was meticulous. He was also, and this matters, a showman. He gave these famous Tuesday lectures, the Leçons du Mardi, where he would bring patients onto a stage in front of an audience of doctors, students, writers, actors, socialites, and demonstrate their symptoms live. It was part medical lecture, part theater. And the condition that drew the biggest crowds, the one that fascinated Charcot most in the 1880s, was hysteria. Now, hysteria is a word we've mostly retired from medicine, and for good reason. It was tangled up with centuries of misogyny, with the idea that women were inherently prone to irrational illness. The word itself comes from the Greek for uterus, hystera, because the ancient Greeks literally believed the condition was caused by a wandering womb moving around inside the body, which is, not how anatomy works. But by Charcot's time, the term had evolved to mean something more specific, even if it was still poorly understood. It referred to patients, mostly women, though not exclusively, who presented with dramatic physical symptoms that had no detectable organic cause. A woman who couldn't move her legs, but whose nerves and muscles were perfectly intact. A woman who had lost all sensation in her hand, in a pattern that followed the shape of a glove rather than the actual distribution of nerves, which is a really important detail, because it meant the paralysis was following the patient's idea of how the body was organized, not how it was actually organized. The symptom was being shaped by a mental map, not a neurological one. And here's where Charcot did something that was genuinely bold for the time. He took hysteria seriously as a real medical condition. He didn't dismiss these patients as faking it. He studied them with the same rigor he'd applied to multiple sclerosis. He photographed them, cataloged their symptoms, tried to identify stages and subtypes. And critically, he used hypnosis, what he called hypnotism, as both a diagnostic tool and a treatment. He found that under hypnosis, he could reproduce hysterical symptoms in patients. He could suggest to a hypnotized woman that her arm was paralyzed, and it would become paralyzed in exactly the same way it would in a hysterical episode. He could also, sometimes, remove symptoms through hypnotic suggestion. Tell a woman under hypnosis that she could move her legs again, and she'd wake up and walk. Think about what that implies. If a symptom can be created and removed by suggestion, by words, by ideas planted in someone's mind while they're in a trance state, then the symptom isn't really about the body at all. It's about the mind, and not the conscious mind, because these patients weren't choosing to be paralyzed. They weren't pretending. They genuinely could not move, genuinely could not see, genuinely could not feel. Something below the level of conscious awareness was producing real, physical symptoms. The subconscious mind was, in a very literal sense, making the body sick. This was the scene that a 29-year-old Sigmund Freud walked into when he arrived at the Salpêtrière on a traveling fellowship in October of 1885. Freud was not yet Freud. Not the bearded icon, not the father of psychoanalysis, not the man whose ideas would saturate 20th century culture so thoroughly that we still talk about Freudian slips at dinner parties. He was a young neurologist, trained in the laboratory tradition, who had spent years looking at cells under microscopes and studying the nervous systems of crayfish and lampreys. He was ambitious. He was broke. He was engaged to a woman named Martha Bernays, and desperate to establish himself so they could finally get married. And he was absolutely electrified by what he saw Charcot doing. What struck Freud wasn't just the hypnosis itself. It was the implication. If the mind could produce physical symptoms without the person knowing why, then there had to be a part of the mind that was active, powerful, and completely hidden from conscious awareness. Not just passively hidden, like Leibniz's faint perceptions that were too quiet to notice. Actively hidden, kept out of awareness for a reason. And figuring out that reason, Freud became convinced, was the key to understanding and treating these mysterious conditions. He went back to Vienna. He started a private practice. And over the next decade, through a combination of clinical observation, collaboration, theoretical speculation, and sheer intellectual audacity, he built the most elaborate and influential model of the unconscious mind that anyone had ever proposed. But he didn't do it alone, and he didn't do it all at once, and the path was messier than the textbook version usually suggests. The collaboration that mattered most in those early years was with Joseph Breuer, an older Viennese physician who had been something of a mentor to Freud. Breuer had a patient, a young woman he called Anna O., whose real name was Bertha Pappenheim, who became one of the most famous case studies in the history of psychology. Anna O. had developed a constellation of hysterical symptoms while caring for her dying father. Paralysis, vision problems, difficulty speaking, hallucinations. Breuer found that when he put her under hypnosis and encouraged her to talk about her symptoms, to trace them back to specific memories and emotional experiences, the symptoms would sometimes disappear. Anna O. herself called this process the talking cure, and that phrase, coined by a patient in the early 1880s, would come to describe an entire tradition of treatment that persists to this day. What Breuer and Freud took from the case of Anna O. and from other patients like her was a specific theory about how the unconscious mind could make you sick. The idea went something like this. When a person experiences something intensely emotional, something frightening, shameful, painful, and they can't fully process that experience, can't express the emotions associated with it, the memory and its attached feelings don't just disappear. They get pushed down, shoved out of conscious awareness. Breuer and Freud use the term repression. The mind actively keeps certain thoughts and memories from reaching consciousness because they're too disturbing, too painful, too threatening to the person's sense of themselves. But those repressed memories don't sit quietly in the dark. They're still active, still charged with emotional energy. And that energy has to go somewhere, so it gets converted. And this is where the word conversion in conversion disorder comes from. It gets converted into physical symptoms, the paralyzed arm, the blindness, the seizures. The body is expressing what the mind won't allow itself to think. Now, this is an elegant idea. It's dramatic, it's compelling, and it has a beautiful narrative logic to it. The hidden truth of the psyche leaking out through the body. And for Freud, it was just the beginning. Over the following years, he moved away from hypnosis. He found it unreliable, and not all patients could be hypnotized, and developed instead the technique of free association, where the patient simply says whatever comes to mind, without censoring, without editing. The theory was that if you let the mind wander freely enough, the repressed material would eventually surface, disguised and distorted, but detectable if you knew what to look for. And this is where Freud's model of the mind really starts to take shape, the model that most people have at least a vague sense of even if they've never read a word of Freud. He proposed that the mind has structure, not physical structure, not brain regions you could point to on a scan, but functional structure, different systems with different rules and different agendas. In his earlier work, he talked about the conscious, the preconscious, and the unconscious. The conscious mind is what you're aware of right now, whatever thought is in your head at this moment. The preconscious is stuff that's not currently in awareness, but could be easily retrieved, like your phone number or what you had for breakfast. It's accessible. It's not hidden. And then there's the unconscious, the deep layer, the vast reservoir of repressed memories, forbidden desires, primal urges, childhood experiences that have been pushed out of awareness because they're too threatening to the ego. This is the part that fascinated Freud, and it's the part that would fascinate and infuriate the world for the next century. Later, Freud refined this into the famous three-part model: the id, the ego, and the superego. The id is the oldest, most primitive part of the mind, operating entirely unconsciously, driven by what Freud called the pleasure principle. It wants what it wants, right now, with no regard for reality or morality. The superego is the internalized voice of society, of parents, of moral rules. It's the conscience, the part that says you shouldn't want what you want. And the ego is the poor mediator caught in between, trying to satisfy the ID's demands in ways that are realistic and socially acceptable while keeping the superego from drowning you in guilt. Most of this negotiation, Freud argued, happens unconsciously. You don't experience the conflict directly. You experience the results of it. In your dreams, in your slips of the tongue, in your neurotic symptoms, in the strange and seemingly irrational choices you make. And here's what's really worth sitting with for a moment. Whether or not you buy Freud's specific model, and there are very good reasons to be skeptical of large parts of it, which we'll get into, the core insight is profound. The idea that you have desires and motives you don't know about, that your conscious reasons for doing things might be after-the-fact rationalizations for decisions that were actually made by processes you can't access, that the story you tell yourself about why you did something might be essentially a cover story. That's a destabilizing idea. It means you might not know yourself as well as you think you do. It means introspection, just looking inward and asking yourself why you feel the way you feel, might not be a reliable way to understand your own mind. And Freud wasn't content to keep this idea confined to the clinic. He applied it everywhere, to art, to religion, to civilization itself. He argued that culture is essentially the collective repression of primal instincts, that society works because we all agree unconsciously to suppress our most destructive and selfish urges, and the price we pay for that suppression is neurosis, anxiety, a vague and persistent sense of unease. It's a sweeping, almost grandiose vision, and it made Freud one of the most influential thinkers of the 20th century, right alongside Darwin and Einstein. But it also made him one of the most controversial, because here's the thing about Freud's model of the unconscious. It was built almost entirely on clinical intuition and case studies, not on controlled experiments. And as the 20th century progressed and psychology tried harder and harder to become a rigorous science, that gap between Freud's brilliant storytelling and actual empirical evidence would become a real problem, a problem that would nearly bury the entire concept of the unconscious mind for decades. So let's talk about what happened. Because the backlash against Freud wasn't just academic quibbling. It was a wholesale rejection of an entire way of doing psychology, and it reshaped the field so completely that for most of the 20th century, serious experimental psychologists wouldn't even use the word unconscious. It became almost taboo. And understanding why that happened and what got lost in the process is one of the most important parts of this whole story. The trouble started, really, with a simple question. How do you test any of this? Think about Freud's core claims. He said there's a hidden part of your mind that contains repressed memories and forbidden desires. He said these repressed contents cause symptoms, anxiety, phobias, strange behaviors. And he said the way to access them is through free association, dream interpretation, and years of psychoanalytic therapy, guided by a trained analyst who can recognize the disguised forms these repressed contents take. Now here's the thing about that framework. It's incredibly hard to prove wrong. If a patient agrees with the analyst's interpretation, that's taken as confirmation. If the patient disagrees, that can be interpreted as resistance, which is itself evidence that the interpretation is correct, because why would you resist unless the analyst was getting close to something painful? You see the problem. It's a closed loop. There's no outcome that could disconfirm the theory, because every possible response from the patient can be folded back into the theory as supporting evidence. And that's a fundamental issue if you're trying to do science, because the hallmark of a scientific theory, this goes back to Karl Popper, the philosopher of science, writing in the 1930s, is that it has to be falsifiable. There has to be some observation, some result, that could in principle prove it wrong. If nothing could ever count as evidence against your theory, then your theory isn't really explaining anything. It's just a story that fits everything after the fact. Popper actually used Freud as one of his primary examples of a non-falsifiable theory, right alongside astrology, and that comparison stung. It was meant to sting. Popper wasn't saying Freud was stupid or that psychoanalysis was worthless as a therapeutic practice. He was saying it didn't qualify as science in the way that, say, Einstein's theory of relativity qualified as science. Einstein's theory made specific, testable predictions. You could go out and check them. And if the observations didn't match, the theory would be in trouble. Freud's theory didn't work that way. It explained everything, which meant it explained nothing. Now, while philosophers like Popper were attacking Freud from one direction, a completely different movement was attacking from another. And this one came from inside psychology itself. This was behaviorism, and it would dominate American psychology for roughly half a century, from the 1920s through the 1960s. And to understand behaviorism, you need to understand the temperament of the people who created it, because they were, in a very real sense, the opposite of Freud in almost every way. The key figure here is John B. Watson, and he's a fascinating character. Watson was born in 1878 in a small town in South Carolina. His father was a drinker who eventually left the family. Watson was, by his own account, a troublemaker as a kid. Got arrested twice before he was even out of his teens. But he was also brilliant, and he clawed his way through Furman University, and then got a PhD at the University of Chicago, studying animal behavior. And the thing about studying animals is that you can't ask a rat what it's feeling. You can't ask a pigeon about its unconscious desires. All you can observe is what the animal does, its behavior, what it does when you present a stimulus, how it changes what it does when you reward or punish certain actions. And Watson looked at this clean, observable, measurable approach to studying minds and thought. Why aren't we doing this with humans? In 1913, Watson published what's sometimes called the Behaviorist Manifesto. It was an article titled "Psychology as the Behaviorist Views It," and it basically declared war on everything that had come before. Watson argued that psychology should abandon all talk of consciousness, mental states, feelings, desires, and especially anything as murky and unobservable as the unconscious. Psychology, he said, should study only behavior, observable, measurable behavior, stimulus and response, what goes in, what comes out. Everything in between, all that internal mental stuff, was a black box, and real scientists shouldn't waste their time speculating about what's inside a black box they can't open. This was radical, and it was enormously appealing to a generation of psychologists who were tired of being looked down on by physicists and chemists and biologists. Those fields dealt with things you could see and measure. Psychology dealt with introspection and dream interpretation and case studies of individual patients, and it felt soft, unscientific, embarrassing. Watson offered a way out. Become rigorous, become experimental, study what you can actually observe, and forget about the unconscious. That's just Freudian mythology dressed up as science. Watson's most famous experiment, and also his most ethically troubling one, was the Little Albert study in 1920. He took a 9-month-old baby, known in the literature as Little Albert, and demonstrated that you can create a phobia through simple conditioning. The baby was shown a white rat, and every time the rat appeared, Watson made a loud, frightening noise behind the baby's head. After several pairings, the baby became terrified of the white rat, and also of other white, furry things, like a rabbit, a fur coat, even a Santa Claus mask. Watson's point was that you didn't need to invoke unconscious complexes or repressed memories to explain a phobia. You just needed stimulus-response conditioning. The fear was learned through a simple, observable mechanism. No hidden depths required. Now, there's a lot to criticize about this experiment. The ethics are appalling by modern standards. The baby was never deconditioned, and we're not entirely sure what happened to little Albert afterward. There's been a long-running debate among historians about his identity and his later life. But the theoretical point landed hard. And when B.F. Skinner came along a generation later and extended behaviorism into an even more comprehensive system, showing how behavior could be shaped through reinforcement schedules, how incredibly complex behaviors could be built up from simple reward and punishment contingencies, the behaviorist program seemed unstoppable. Here's what's really interesting about this period, though. For roughly 40 years, mainstream experimental psychology essentially pretended the unconscious mind didn't exist. The word almost disappeared from serious research journals. If you were a young psychologist in the 1940s or 1950s, and you wanted a career in academia, you studied learning, you studied conditioning, you studied stimulus-response associations. You did not study the unconscious. That was for psychoanalysts in their private practices, not for scientists in their laboratories. And the psychoanalysts, for their part, largely ignored the experimentalists. The two worlds barely talked to each other. It was as if psychology had split into two completely separate disciplines that happened to share a name. But here's the thing about trying to study the mind without ever talking about what happens inside the mind. It works for a while. It works beautifully, for simple learning, for conditioning, for understanding how habits form and how behaviors can be modified. But it starts to break down when you try to explain anything more complex. Language, for instance. How do children learn language? The behaviorist answer was that they learn it through imitation and reinforcement. They hear words, they repeat them, they get rewarded when they say the right thing. But in 1959, a young linguist named Noam Chomsky published a devastating review of Skinner's book on verbal behavior, and he pointed out something that seems obvious once you hear it, but that behaviorism had no good answer for. Children say things they've never heard before. They generate novel sentences. A 3-year-old will say something like, "I go to the store," which is wrong. But it's wrong in a very interesting way, because the child has never heard an adult say, "goed." The child has extracted a rule, add ed to make past tense, and applied it creatively, even to an irregular verb where it doesn't work. That's not imitation. That's not stimulus response. That's an internal mental process, a rule operating inside the black box that Watson and Skinner said we should ignore. Chomsky's critique was part of a much larger shift that was happening in the late 1950s and 1960s, and it's usually called the cognitive revolution. And this is where the story of the unconscious mind takes a completely unexpected turn, because the cognitive revolution didn't bring back Freud. It didn't vindicate psychoanalysis. What it did was something much stranger and, in a way, much more profound. It revealed an unconscious mind that Freud had never imagined, one that had nothing to do with repressed desires or childhood trauma, and everything to do with information processing. The cognitive revolution was driven partly by new ideas and partly by new technology. The new ideas came from information theory, from linguistics, from computer science. And the new technology, this is crucial, was the digital computer. Because once you had computers, you had a new metaphor for the mind. The mind wasn't a steam engine, the way 19th century thinkers had imagined it. It wasn't a hydraulic system of pressures and flows, the way Freud had conceptualized it. It was an information processor. It took in data, transformed it, stored it, retrieved it, and produced outputs. And here's the key insight. Most of that processing happened automatically, without any conscious awareness. Not because the information was being repressed, not because it was too threatening to face, but simply because that's how the system was designed. Consciousness was like the user interface on a computer. It showed you the results, but it didn't show you the millions of computational steps that produced those results. Think about what that means. When you recognize a friend's face across a crowded room, you don't consciously work through the process. You don't think, okay, let me analyze the distance between the eyes, the shape of the nose, the ratio of forehead to chin, cross-reference with my stored database of faces. You just see your friend, instantly, effortlessly, but your brain is doing all of that computational work. It has to be, because that's the only way the recognition could happen. You're just not aware of it. The processing is unconscious, not repressed, not hidden because it's threatening, just unconscious because that's how efficient information processing works. You don't need to be aware of every step to get the result. This was a fundamentally different kind of unconscious than Freud's. Freud's unconscious was dramatic. It was full of forbidden wishes and traumatic memories and dark impulses straining against the barriers of repression. The cognitive unconscious was, by comparison, almost mundane. It was the vast machinery of perception, memory, language, and decision-making that operates below the surface simply because it would be impossibly slow and inefficient to do it all consciously. And yet, in some ways, this new unconscious was even more radical than Freud's, because Freud had still assumed that the most important mental work, reasoning, deciding, understanding, happened consciously. He thought the unconscious was powerful but primitive, driven by pleasure and aggression. The cognitive revolution suggested something different. It suggested that sophisticated, intelligent processing was happening unconsciously all the time, and that consciousness might be less like the CEO of a company and more like the press secretary, the person who comes out after the decisions have already been made and explains them to the public. One of the earliest and most striking demonstrations of this came from a psychologist named George Sperling, working at Bell Labs in 1960. Sperling was interested in a simple question: how much visual information can you take in at a glance? He flashed arrays of letters on a screen for just 50 milliseconds, that's 1/20th of a second, and then asked people to report what they'd seen. People could typically report about 4 or 5 letters. But Sperling suspected they were actually seeing more than that, and the information was just fading before they could report it. So he tried something clever. Right after the flash, he played a tone, a high tone, a medium tone, or a low tone, that told people which row of letters to report. And when he did that, people could report almost any letter from the cued row, no matter which row was cued, which meant they had briefly seen all the letters. The full array was available to their visual system. But it decayed so rapidly that by the time they tried to consciously report it, most of it was gone. The information had been processed, registered, held for a fraction of a second, and then lost, all without ever reaching conscious awareness. And that was just the beginning. Throughout the 1960s and 1970s, experiment after experiment revealed the staggering amount of processing happening beneath the surface of awareness. There was the work on selective attention, the famous cocktail party effect, where you can focus on one conversation in a noisy room and tune out everything else. And yet, if someone across the room says your name, you snap to attention, which means some part of your mind was monitoring those other conversations all along, even though you weren't conscious of any of them. Your brain was quietly, efficiently scanning every voice in that room, parsing words, checking for relevance, and discarding almost all of it, except when something important slipped through the filter. And that raises a really fascinating question. Who decides what's important? Because it's not you, not the conscious you. Something else is making that call. This is where the research gets genuinely strange, and I think it's worth slowing down here, because the experiments from this era really changed how scientists thought about the mind. One of the key figures was a British psychologist named Anthony Marcel, working at Cambridge in the late 1970s and early 1980s. Marcel was interested in what happens when you process a word without being aware of it. So he designed a series of experiments using something called masked priming. Here's how it works. You flash a word on a screen, say the word doctor, but you flash it so briefly, and you immediately follow it with a visual pattern, a mask, that essentially overwrites the image before the person can consciously register it. People will tell you, honestly, that they saw nothing, no word, just a flash and a pattern. They have no idea a word was even presented. But then, and here's the beautiful part, you ask them to respond to a second word, one they can clearly see, like nurse. And what Marcel found was that people responded faster to nurse after being unconsciously exposed to doctor. The hidden word had primed them. It had activated related concepts in their semantic network, speeded up their processing, shaped their response, all without ever entering awareness. The word doctor had been read, understood, and connected to related meanings entirely in the dark, entirely below the threshold of consciousness. Think about what that means for a second. Your brain can read, it can understand language, it can activate meaning, and it can do all of this without you knowing it happened. That's not some vague Freudian notion of repressed desires lurking in the shadows. This is precise, measurable cognitive processing, reading and comprehension happening automatically and unconsciously. Marcel's work was controversial at first. Some researchers questioned whether the masking was truly effective, whether subjects really couldn't see the primed word. But over the following decades, the basic finding was replicated hundreds of times with increasingly rigorous controls. Subliminal priming became one of the most robust findings in cognitive psychology, and it opened the door to a much bigger realization that the unconscious mind isn't just storing memories or filtering noise, it's actively thinking. Now, around the same time Marcel was doing his priming experiments, another line of research was developing that would become one of the most talked about and most unsettling findings in all of neuroscience. This one came from a physiologist named Benjamin Libet, working at the University of California, San Francisco. Libet was interested in the timing of conscious decisions. Specifically, he wanted to know, when you decide to move your hand, when does that decision actually happen? It sounds like a simple question, but the answer turned out to be anything but simple. Here's what Libet did. He asked subjects to sit in front of a clock, a special clock with a dot moving around the face, and to flex their wrist whenever they felt like it. Completely voluntary, completely spontaneous. Just move when you want to move. While they did this, he monitored their brain activity using electrodes on the scalp, specifically looking for something called the Readiness-Potential, a buildup of electrical activity in the motor cortex that precedes voluntary movement. Neuroscientists had known about the Readiness-Potential since the 1960s, when it was first described by Hans Helmut Kornhuber and Ludwig Dicke in Germany. It typically begins about a second or more before the actual movement. So Libet's question was, where does the conscious decision fit in? Does the person first decide to move, and then the brain starts preparing? Or does the brain start preparing first? And here's the kicker. The readiness potential began, on average, about 550 milliseconds before the movement. But subjects reported becoming consciously aware of their intention to move only about 200 milliseconds before the movement, which means the brain had already been gearing up for over a third of a second before the person felt like they had decided anything. The unconscious preparation came first. The conscious sense of willing the action came second. The movement came third. When Libet published these results in 1983, they sent shockwaves through philosophy and neuroscience alike. Because on the surface, it looked like free will might be an illusion. It looked like your brain decides what to do, and then, a few hundred milliseconds later, it kindly informs you of the decision and lets you feel like you made it. You're not the author of your actions. You're the narrator, constructing a story about choices that were already made for you by unconscious processes. Now, I should say, the interpretation of Libet's experiments is still debated to this day. Libet himself didn't think free will was dead. He pointed out that even though the readiness potential started before conscious awareness, subjects still had about 150 milliseconds after becoming aware of the urge during which they could veto the action. They could choose not to move. So maybe free will isn't about initiating actions, but about vetoing them. Maybe consciousness is less like a CEO giving orders and more like a quality control inspector, who can stop the assembly line. Other researchers have questioned whether the readiness potential really represents a decision at all, or whether it's just neural noise that crosses a threshold. Some have argued that the clock-watching method itself distorts the timing of awareness. These are real criticisms, and the debate is far from settled. But here's what matters for our purposes tonight. Whatever the final verdict on Libet's specific experiments, the broader point they illustrated has been confirmed again and again. An enormous amount of the processing that leads to your actions, your judgments, your preferences, your decisions. It happens before you're aware of it. Consciousness arrives late to the party, and sometimes it arrives so late that it's really just there to take credit. This idea that consciousness might be more like a press secretary than a president, more narrator than decision-maker, got a huge boost from another direction entirely, one that came from studying people whose brains had been literally split in two. These were the famous split-brain patients, and the research was led by Roger Sperry and his student Michael Gazzaniga, starting in the 1960s at Caltech. The patients were people with severe epilepsy who had undergone a radical surgery, cutting the corpus callosum, the thick bundle of nerve fibers that connects the left and right hemispheres of the brain. The surgery was a last resort to stop seizures from spreading from one hemisphere to the other, and it actually worked reasonably well for that purpose. But it had a remarkable side effect. It created two semi-independent minds in one skull. Here's why that matters. In most people, the left hemisphere controls the right hand and processes information from the right visual field, while the right hemisphere controls the left hand and processes the left visual field. Normally, the two hemispheres share information instantly through the corpus callosum, so you never notice the division. But in split-brain patients, that bridge is gone. And Gazzaniga figured out how to exploit this. He would flash a word or an image to just one visual field. Say he'd flash the word walk to the right hemisphere only. The patient couldn't say what they'd seen, because the right hemisphere doesn't control speech in most people. That's a left hemisphere job. But the patient would get up and start walking, and when Gazzaniga asked them why they were walking, the left hemisphere, which had no idea about the flashed word, would instantly confabulate a reason. Oh, I'm going to get a Coke, or I wanted to stretch my legs. The left hemisphere made up a plausible story on the spot, with complete confidence, having no idea it was fabricating. Let that sink in for a moment. The conscious, speaking part of the brain didn't know the real reason for the behavior, but instead of saying, "I don't know," it invented an explanation and believed it completely. Gazzaniga called this the interpreter, a module in the left hemisphere, whose job is to construct narratives that make sense of whatever the person is doing, feeling, or experiencing, regardless of whether those narratives are accurate. And here's the thing that should keep you up at night. Well, actually, we're trying to help you sleep, so maybe it shouldn't keep you up. But the unsettling implication is that this interpreter is running in all of us all the time. You don't need a split brain for it to operate. Every time you make a decision based on gut feeling, every time you choose something for reasons you can't quite articulate, and then come up with a perfectly logical explanation after the fact, that's the interpreter at work. You're confabulating. You're telling yourself a story about why you did what you did, and the story might be completely wrong, and you'd never know. This connects back to something we touched on earlier, the idea that consciousness might be more like a press secretary. Gazzaniga's split-brain work gave that metaphor real teeth. Because now you could literally see it happening in the lab. You could watch someone's brain generate a behavior from one hemisphere and then watch the other hemisphere spin a false but convincing narrative about it. And the person wasn't lying. They genuinely believed their explanation. The interpreter doesn't know it's making things up. It's doing its job, which is to create coherence, to make the world make sense, to give you a unified story about who you are and why you do what you do, even when the real reasons are hidden from you. By the mid-1980s, these converging lines of evidence, Sperling's iconic memory, Marcel's subliminal priming, Libet's readiness-potential, Gazzaniga's split-brain confabulations, were building a picture of the mind that was radically different from what most people assumed. The conscious mind wasn't running the show. It was more like a small, well-lit room in an enormous dark mansion. Most of the activity was happening in rooms you couldn't see, down hallways you didn't know existed. And the little lit room? It was getting summaries, reports, and sometimes outright fabrications from the rest of the house, and it was doing its best to make sense of them. But here's where the story takes another turn, because all of this, all the lab experiments, all the clever paradigms with flashing letters and ticking clocks, it was still, in a sense, studying the unconscious mind in artificial conditions. What researchers really wanted to know was how unconscious processing shapes the messy, complicated decisions of everyday life. And that question led to a whole new wave of research in the 1990s and 2000s, driven by advances in brain imaging and by a psychologist at Yale named John Bargh, who became obsessed with a deceptively simple idea that your behavior is being shaped constantly and powerfully by things you encounter in your environment without ever noticing them. Bargh called this automaticity, and his experiments on priming were some of the most talked about studies in all of psychology. One of the earliest and most famous was published in 1996 with his colleagues Mark Chen and Laura Burrows. The setup was almost comically simple. They brought participants into the lab and gave them what looked like a standard language test, a scrambled sentence task where you rearrange words to form grammatically correct sentences. Easy enough. But hidden inside the scrambled words were terms related to elderly stereotypes. Words like Florida, gray, bingo, wrinkle, forgetful. Not every word, just enough to prime the concept of old age without anyone catching on. The participants had no idea what the study was really about. They thought it was a language exercise. And here's the thing. The actual experiment wasn't the word task at all. The real measurement happened after, when the participants finished and walked down the hallway to leave the building. Research assistants, hidden from view, timed how long it took them to walk down that corridor. And the people who had been primed with elderly-related words walked significantly slower than the control group. Let that sink in for a second. Nobody told them to walk slowly. Nobody mentioned aging or movement or speed. They just unscrambled some sentences with certain words embedded in them, and their bodies responded. Their walking pace changed. Their conscious minds had no idea anything had happened. But somewhere in the vast machinery of unconscious processing, the concept of old had been activated, and it rippled outward into motor behavior. Bargh saw this as evidence that our social environment is constantly priming us in ways we never detect. The words on a billboard, the mood of the person sitting next to you on the train, the temperature of the coffee cup in your hand, all of these things, he argued, are feeding into your unconscious processing systems and nudging your behavior, your judgments, your emotions, without you ever being aware of it. Now, I should tell you, and this is important, that this particular study, the elderly walking study, became one of the most famous examples in what later turned into psychology's replication crisis. In 2012, A Belgian researcher named Stéphane Doyen tried to replicate the experiment and couldn't get the same result, at least not straightforwardly. His team found that the effect only appeared when the experimenters themselves expected it to appear, suggesting that subtle cues from the researchers, their body language, their pacing, tiny unconscious signals, might have been influencing the participants rather than the priming words alone. This kicked off a firestorm. Other priming studies started failing to replicate too, and for a while, it looked like the whole field of social priming might collapse. But here's what's interesting, and what often gets lost in the headlines. The replication crisis didn't disprove unconscious processing. What it did was force researchers to be much more careful about which effects were real and robust, and which ones were fragile or dependent on very specific conditions. Some priming effects held up beautifully under replication. Others didn't. And the conversation shifted from, does unconscious priming exist? Which, yes, it clearly does. Marcel's work and decades of cognitive priming research had established that beyond doubt, to how far does it reach and under what conditions does it shape complex social behavior? That's a much more nuanced and honest question. And it's the question researchers are still working on today. So let's set Barg aside for a moment and talk about what was happening in parallel, because the 1990s brought something that changed the entire game for studying the unconscious mind, and that was functional brain imaging. Specifically, functional magnetic resonance imaging, fMRI. Before fMRI, if you wanted to know what the brain was doing during a task, your options were limited. You could study patients with brain damage and see what abilities they lost, which is what Gazzaniga and others had been doing. You could use electroencephalography, EEG, which measures electrical activity at the scalp and gives you excellent timing information but terrible spatial resolution. You know when something happened, but not precisely where. Or you could do what Libet did and work with neurosurgical patients who already had electrodes implanted for medical reasons. All of these approaches yielded incredible insights, but they all had serious limitations. fMRI changed that. For the first time, you could watch a healthy person's brain in action in real time, with reasonably good spatial resolution. You could see which brain regions lit up, which areas showed increased blood flow, indicating increased neural activity, while someone performed a task. And almost immediately, researchers started using fMRI to ask questions about unconscious processing. One of the most striking early findings came from studies of what's called blind sight. This is a phenomenon that had been known since the 1970s, primarily through the work of Lawrence Weisskranz at Oxford. Patients with damage to their primary visual cortex, the main area in the back of the brain that processes visual information, would report being completely blind in part of their visual field. If you held up an object in their blind region, they'd say they couldn't see anything, nothing at all. But if you forced them to guess, just point to where you think the object is, even though you can't see it. They could do it with remarkable accuracy, way above chance. They were perceiving visual information without any conscious experience of seeing. The visual data was getting into their brain through alternative neural pathways, bypassing the damaged primary visual cortex, reaching areas involved in spatial processing and motor control, and influencing behavior, all without producing the subjective experience of vision. With fMRI, researchers could now see exactly which brain areas were active during blind sight. And what they found was fascinating. Subcortical structures, older, evolutionarily more ancient parts of the brain, like the superior colliculus and the pulvinar nucleus of the thalamus, were processing the visual information and routing it to motor and spatial areas. The information never reached the cortical areas associated with conscious visual awareness, but it was being processed, used, and acted upon. The brain was seeing without the person knowing it was seeing. Think about what that means for a moment. It's not just that unconscious processing exists as some vague background hum. It has specific neural architecture. There are actual pathways, actual brain structures, doing real computational work that never breaks through into your awareness. And blindsight is just one example. Throughout the late 1990s and into the 2000s, fMRI studies kept revealing unconscious processing in domain after domain. There's a beautiful line of research on unconscious emotion processing that really drives this home. In the mid-1990s, a neuroscientist named Joseph Ledoux at New York University mapped out what he called the low road of fear processing. Here's the setup. When you encounter something potentially threatening, say a snake-shaped object on a hiking trail, the visual information from your eyes travels to a relay station in the brain called the thalamus. From there, it can take two routes. The high road sends the information up to the visual cortex for detailed processing: shape, color, texture, context. That takes time, maybe a quarter of a second or more. But there's also a low road, a faster, cruder pathway that sends a rough sketch of the visual information directly from the thalamus to the amygdala, which is the brain's threat detection center. The amygdala doesn't need a detailed picture. It just needs a rough shape, something long, thin, curved, and it triggers a fear response. Your heart rate spikes, your muscles tense, stress hormones flood your bloodstream, and you jump back from the trail before you've even consciously registered what you're looking at. Only after, maybe a full second later, does the high road deliver the detailed analysis, and your conscious mind says, "Oh, it's just a stick." Ledoux's point was that the emotional response came first, driven by unconscious processing, and the conscious perception came second. You feel afraid before you know why. And this isn't a flaw in the system. It's a feature. In evolutionary terms, it's far better to jump away from 100 sticks than to calmly evaluate one actual snake. The cost of a false alarm is trivial. The cost of a miss is death. So the brain evolved to let the unconscious threat detection system act first and ask questions later. And this connects back to something we touched on earlier, that idea of consciousness as press secretary rather than president. Ledoux's work showed that for something as fundamental as fear, arguably one of the most important experiences any organism can have, the unconscious system is making the critical decision: jump, freeze, run. The conscious mind gets notified after the fact and then constructs a narrative about what happened and why. I saw a snake and got scared. But the actual sequence was unconscious detection, physical response, then conscious awareness. The story you tell yourself has the order backwards. Now, around this same time, another researcher was approaching the unconscious from a completely different angle, and his work would become some of the most influential and controversial in all of modern psychology. His name was Daniel Kahneman, and although he's best known for winning the Nobel Prize in Economics in 2002, which is remarkable for a psychologist, his real contribution was building a comprehensive framework for understanding two fundamentally different modes of thinking. He didn't discover these modes from scratch. The distinction between fast, automatic processing and slow, deliberate reasoning had been floating around cognitive psychology for decades in various forms, under various names. But Kahneman, working with his longtime collaborator Amos Tversky until Tversky's death in 1996, synthesized decades of research into a framework so clear and so useful that it reshaped how scientists, economists, policymakers, and eventually the general public thought about the mind. Kahneman called them System 1 and System 2, and those names stuck. System 1 is fast, automatic, effortless, and largely unconscious. It's what recognizes a face in a crowd, reads the emotional tone of someone's voice, completes the phrase, bread and with butter, before you even think about it. It runs on pattern recognition, association, and heuristics. Mental shortcuts that usually work well enough, but sometimes lead you astray. System 2 is slow, deliberate, effortful, and conscious. It's what you engage when you multiply 17 by 24 in your head, or carefully compare two insurance policies, or try to follow a complicated argument. It requires attention, and attention is a limited resource. You can't do two System 2 tasks at once without one of them suffering. Here's the thing that made Kahneman's framework so powerful. It wasn't just a description. It was a research program. He and Tversky had spent decades documenting the specific ways that System 1's shortcuts, its heuristics, lead to systematic errors in judgment. They called these errors cognitive biases, and the list they compiled is staggering. There's the anchoring effect, where your judgment about a number is pulled toward whatever number you happen to encounter recently, even if it's completely irrelevant. There's the availability heuristic, where you judge the likelihood of events based on how easily examples come to mind, which is why people overestimate the risk of plane crashes and underestimate the risk of heart disease, because plane crashes make vivid, memorable news stories and heart disease doesn't. There's loss aversion, where losing $50 feels roughly twice as painful as gaining $50 feels good, which means people make irrational decisions to avoid losses, even when the math clearly favors taking the risk. Every single one of these biases is a product of unconscious processing. System 1 is making these judgments automatically, below the threshold of awareness, and handing the results to System 2 as if they were objective assessments of reality. And System 2, which is lazy by nature, it has to be because deliberate thought is metabolically expensive, usually just accepts what System 1 delivers without checking the work. You don't feel yourself being anchored. You don't notice the availability heuristic distorting your risk assessment. These processes are invisible to you, and that invisibility is exactly what makes them so powerful. Kahneman published his masterwork, Thinking, Fast and Slow, in 2011, but the research behind it stretched back to the early 1970s. And what made it so resonant, I think, is that it gave ordinary people a vocabulary for something they'd always sensed, but couldn't articulate. That their own minds were doing things behind the scenes, making judgments and decisions that felt like reasoned conclusions, but were actually the output of fast, automatic, unconscious processes that could be systematically wrong. It was Helmholtz's unconscious inference, updated for the modern age, and armed with decades of experimental evidence showing exactly how and when those inferences go wrong. Kahneman and Tversky had essentially mapped the error patterns of the unconscious mind, and in doing so, they'd revealed its logic, because the errors weren't random. They were systematic, predictable, and that predictability told you something profound about the machinery generating them. Think about that for a second. If your unconscious mistakes were random, that would just be noise, meaningless static. But the fact that millions of people make the same mistakes in the same situations, over and over, in every culture, researchers have tested. That's a signal. That's a fingerprint of the underlying system. It's like diagnosing a car engine by listening to the specific way it misfires. The pattern of errors tells you how the engine is built. And here's where Kahneman's work connects to something even bigger, something that was happening simultaneously in a completely different corner of science. Because right around the same time that behavioral economists were cataloging the biases of System 1, neuroscientists were starting to ask a related but distinct question. Not just what the unconscious mind does, but how much of the brain's total activity is actually unconscious. And the answer they were converging on was staggering. You've probably heard the old myth that we only use 10% of our brains. That's not true. We use all of it. But here's what is true, and it's almost stranger. The vast majority of what your brain is doing at any given moment is completely outside your conscious awareness. Some estimates suggest that conscious processing accounts for a vanishingly small fraction of total neural activity. Your brain is consuming about 20 watts of power, roughly the same as a dim light bulb, and it's running an unbelievable number of parallel operations every second. Regulating your heartbeat, adjusting your breathing, processing the temperature of the air on your skin, monitoring sounds in the environment for potential threats, maintaining your balance, running your immune system, consolidating memories, filtering sensory input, predicting what's going to happen next based on patterns it's learned over your entire lifetime. All of this is happening right now as you listen to this, and none of it requires your conscious attention. You don't have to think about keeping your heart beating. You don't have to consciously decide to breathe. Your brain handles it quietly in the background, the way an operating system runs hundreds of processes you never see. And this brings us to something that a neuroscientist named Marcus Rachel stumbled onto in the late 1990s, something that genuinely surprised the field. Rachel was working at Washington University in St. Louis, and he was using PET scans and later fMRI to study brain activity during cognitive tasks. The usual stuff, asking people to do word puzzles or memory tests while lying in a scanner. And like every other neuroimaging researcher, he was comparing brain activity during the task to brain activity during rest, because you need a baseline. You need to know what the brain looks like when it's doing nothing, so you can see what changes when it's doing something. But here's what Rachel noticed. The brain at rest wasn't doing nothing. It was doing a lot. There was a consistent pattern of activity, specific regions lighting up together, that appeared whenever subjects weren't focused on an external task, and when they started doing the task, those regions actually decreased in activity. It was as if the brain had a default mode of operation, a kind of baseline hum of internal processing that got interrupted when you had to pay attention to something in the outside world. Rachel published a landmark paper in 2001, identifying what he called the default mode network, a set of interconnected brain regions, including the medial prefrontal cortex, the posterior cingulate cortex, and parts of the temporal lobe that are most active when you're not focused on the external environment. When you're daydreaming, when you're mind wandering, when you're lying in bed at night, maybe right now, and your thoughts are just drifting from one thing to another without any particular direction. And this was a revelation, because it meant the brain isn't a reactive machine that sits idle until something happens and then responds. It's proactively busy all the time. The default mode network is involved in self-referential thinking about yourself, your past, your future, your relationships, your identity. It's involved in mental simulation, in imagining scenarios, in what researchers sometimes call mental time travel, the ability to project yourself forward into possible futures or backward into memories. And almost all of this happens unconsciously. You don't decide to activate your default mode network. It activates on its own the moment your attention relaxes, and it starts doing this incredibly sophisticated internal work that you're barely aware of. Now, you might be thinking, okay, but mind-wandering and daydreaming, that's not exactly the unconscious in the Freudian sense, right? And you're right, it's not. But here's what's interesting. The default mode network research revealed that the brain is never not working. There is no idle state. And much of what it's doing in those idle moments turns out to be critically important. Studies have shown that default mode network activity is associated with creativity, with problem solving, with the kind of insight that seems to come from nowhere. You're in the shower, you're on a walk, you're half asleep, and suddenly the answer to something you've been struggling with just appears in your mind, fully formed, as if someone handed it to you. That's not magic. That's your unconscious mind, working on the problem in the background while your conscious attention was elsewhere, and finally arriving at a solution that it then delivers to consciousness. There's actually a name for this. Psychologists call it the incubation effect, and it's been studied since at least the early 20th century. The idea is simple. Sometimes, when you're stuck on a problem, the best thing you can do is stop thinking about it. Walk away, do something else, sleep on it. And when you come back, the answer is there. For a long time, this seemed almost mystical, but the default mode network gives us a plausible neural mechanism. When you stop consciously grinding on a problem, your brain doesn't stop working on it. It just shifts the processing to unconscious networks that operate differently, more associatively, more creatively, making connections between distant concepts that your focused, logical, conscious mind would never think to link. And this connects beautifully to something we touched on earlier, the idea that consciousness is like a press secretary rather than a president. The default mode network research deepens that metaphor, because what it suggests is that the president, the vast unconscious processing network, isn't just handling routine administrative tasks. It's doing genuinely creative, high-level cognitive work. It's simulating futures. It's integrating information from across your entire life history. It's solving problems. And then, when it has something worth reporting, it sends the result up to consciousness, to the press secretary, who experiences it as a sudden insight, an intuition, a gut feeling, and then constructs a narrative about where that idea came from. I just had a flash of inspiration, you say. But that flash was the end product of enormous unconscious computation, not a spontaneous event. So by the early 2000s, the picture that was emerging from multiple converging lines of research, from cognitive psychology, from behavioral economics, from neuroscience, from neuroimaging, was remarkably consistent. The unconscious mind wasn't the primitive, irrational dungeon that Freud had imagined, full of repressed desires and dark impulses, and it wasn't the blank slate that the behaviorists had insisted on either. It was something far more interesting, a vast, sophisticated parallel processing system that handles the overwhelming majority of your mental life, from perception to emotion to decision-making to creativity. It has its own logic, its own biases, its own strengths and weaknesses. It can be systematically wrong in predictable ways, as Kahneman showed. But it can also be breathtakingly right, arriving at solutions and judgments that conscious deliberation could never match. And this brings us to something that's become increasingly important in the last 2 decades: the relationship between unconscious processing and expertise. Because one of the most fascinating things about the unconscious mind is that it's trainable. It learns. And the way it learns has enormous implications for how we think about skill mastery, and what it means to be really good at something. Let's talk about that for a second. Think about learning to drive a car. When you first started, everything was conscious. You had to think about every single action. Check the mirrors, signal, check the blind spot, turn the wheel this much, ease off the clutch at this rate, watch the speed, watch the road, watch the other cars. It was exhausting. Your working memory was maxed out. You probably couldn't even hold a conversation while driving because every scrap of your conscious processing power was devoted to the task. But now, if you've been driving for years, you do all of that automatically. You can drive a familiar route while having a deep conversation, listening to a podcast, thinking about what you're going to make for dinner. The mechanical skills of driving have been handed off to unconscious processing. They've been automated. And this isn't just muscle memory, although that's part of it. It's genuine cognitive automation. Your unconscious mind is reading the road, predicting what other drivers will do, maintaining safe following distances, adjusting speed for curves, all without any conscious effort. This process, the gradual transfer of skills from conscious to unconscious processing, is one of the most important things the brain does. Psychologists sometimes call it automatization, and it's essentially the mechanism behind all expertise. A chess grandmaster doesn't consciously analyze every possible move. They look at the board and patterns leap out at them, unconsciously, instantly, because they've internalized tens of thousands of board positions over years of practice. A skilled musician doesn't think about where to put their fingers. An experienced doctor walking into a patient's room sometimes just knows something is wrong before they can articulate what. Their unconscious mind has pattern matched against thousands of previous patients and flagged an anomaly that conscious analysis hasn't caught up to yet. This is what the psychologist Gary Klein calls recognition-primed decision-making, and he studied it extensively in the 1990s by interviewing firefighters, military commanders, intensive care nurses, people who make life and death decisions under extreme time pressure. And what he found was that these experts almost never made decisions the way classical decision theory said they should, carefully weighing options, comparing alternatives, calculating probabilities. Instead, they would assess the situation, and a course of action would simply present itself. It felt like intuition. But it wasn't mystical. It was the product of years of experience that had trained their unconscious pattern recognition systems to an extraordinary degree of sophistication. And here's what's really beautiful about this. It closes a circle that stretches all the way back to Helmholtz in the 1860s. Remember his unconscious inference, the idea that your brain is constantly making rapid automatic judgments based on prior experience and presenting the results to consciousness as if they were direct perceptions of reality. Klein's expert firefighters are doing exactly the same thing, just at a higher level of complexity. The mechanism is the same. The unconscious mind takes in information, matches it against learned patterns, draws an inference, and delivers the conclusion to consciousness. The firefighter who just knows the floor is about to collapse is running the same basic cognitive operation as your visual system when it just knows that one object is farther away than another based on subtle depth cues. It's unconscious inference all the way up. But there's a tension here, and it's one that researchers are still working through. Because if unconscious processing can be so brilliant, if it can drive expert intuition, creative insight, effortless skill, then how do we square that with Kahneman's work, showing that it's also the source of systematic biases and errors? How can the same system be both the genius and the fool? The answer, it turns out, depends on something deceptively simple: the quality of the environment in which the unconscious mind learned its patterns. And this is where a really productive debate emerged between Kahneman himself and Gary Klein, two researchers who seem to be saying opposite things about the same system. Kahneman had spent decades documenting all the ways unconscious, automatic thinking leads us astray: anchoring effects, availability bias, overconfidence, the whole catalog of heuristics that fire quickly but miss the mark in predictable ways. And Klein had spent just as long documenting all the ways unconscious, automatic thinking leads experts to brilliance: firefighters sensing danger before they can articulate why, nurses spotting a sick infant from across the room before any test results come back, fighter pilots making split-second decisions that save lives. So who was right? Were our fast, automatic systems trustworthy or treacherous? And here's what's wonderful. Instead of just arguing past each other, Kahneman and Klein actually sat down together and wrote a joint paper. It was published in 2009 in the journal American Psychologist. And it's one of those rare academic collaborations where two people who genuinely disagreed worked through their disagreement in public, on the page, and came out the other side with something neither could have reached alone. The paper was called Conditions for Intuitive Expertise: A Failure to Disagree. And that subtitle tells you everything. They expected to disagree. They tried to disagree. And they found, when they really got into it, that they were mostly talking about different situations. The key insight, and this is one of those ideas that sounds simple but rearranges how you think about a lot of things, is that expert intuition is trustworthy when two conditions are met. First, the environment has to be sufficiently regular. There have to be stable, repeatable patterns that exist to be learned. And second, the person has to have had adequate opportunity to learn those patterns through prolonged practice with clear feedback. That's it. Two conditions: regularity and practice. Think about what that means. A chess grandmaster operates in a highly regular environment. The rules don't change. The pieces always move the same way. Patterns recur across thousands of games, and the grandmaster has spent 10,000 or more hours studying those patterns, playing games, getting immediate feedback. You win or you lose. Your move works or it doesn't. So when a grandmaster glances at a board and just sees the right move, that intuition is trustworthy. The unconscious mind has been trained in a valid environment with reliable feedback. Now compare that to, say, a political pundit predicting election outcomes, or a stock picker trying to beat the market, or a clinical psychologist making a long-term prediction about a patient after a single interview. These environments are what Kahneman and Klein called low-validity environments. They're noisy. They're full of random variation. The patterns, if they exist at all, are weak and unstable, and the feedback is delayed, ambiguous, or absent entirely. The stock picker makes a call, and by the time the outcome is clear, dozens of other variables have intervened, making it nearly impossible to learn the right lessons from experience. In these environments, the unconscious mind still tries to find patterns. That's what it does. It can't help it. But the patterns it finds are often illusory. It's seeing faces in clouds, and the confidence the person feels in their intuition is just as strong as the firefighters, which is what makes it so dangerous. The feeling of knowing doesn't come with a reliability label attached. So the same unconscious system that makes the expert firefighter brilliant makes the overconfident stock picker foolish. The machinery is identical. What differs is the quality of the training data, to borrow a term from machine learning that fits surprisingly well here. Your unconscious mind is, in a very real sense, a pattern recognition engine that's only as good as the patterns it's been fed. Feed it thousands of hours of experience in a regular environment with clear feedback, and it becomes almost supernaturally accurate. Feed it noisy, irregular, ambiguous data, and it becomes a bias machine. Still confident, still fast, still automatic, but systematically wrong. And this reconciliation between Kahneman and Klein doesn't just resolve an academic debate. It gives you something genuinely useful. It gives you a framework for knowing when to trust your gut and when to override it. When you're in a domain where you have deep experience and the environment is stable and patterned, trust the feeling. When you're in unfamiliar territory, or when the situation is genuinely novel, or when the feedback loops are long and murky, slow down. Engage what Kahneman would call System 2. Check your assumptions. Look at the data, because in those moments, your unconscious confidence is not earned. Let that settle for a moment, because it connects to something we touched on earlier, way back when we were talking about the default mode network and incubation. Remember how the DMN seems to do its best creative work when it's been loaded up with relevant information and then left alone? That's another version of the same principle. The unconscious mind needs good raw material. It needs real patterns, real knowledge, real experience to work with. The incubation effect doesn't work if you haven't done the hard conscious work first. You can't just take a shower and expect a breakthrough if you haven't spent hours wrestling with the problem beforehand. The unconscious isn't magic. It's machinery. Extraordinary machinery, but machinery that depends on inputs. And this brings us to something that's become increasingly important in the last couple of decades. The question of how unconscious processing shapes not just our thinking and our expertise, but our social lives, our relationships, our sense of who we are and who other people are. Because it turns out that some of the most consequential work the unconscious mind does isn't about chess or firefighting or solving physics problems. It's about people. There's a researcher named Mahzarin Banaji, a social psychologist who spent much of her career at Harvard, and in the late 1990s, she and her colleague Anthony Greenwald developed something called the Implicit Association Test, or IAT. You may have heard of it. The basic idea is elegant and a little unsettling. The test measures the speed with which you associate different concepts. For example, how quickly you pair faces of different racial groups with positive or negative words. The logic is that if your unconscious mind holds an association between, say, a particular racial group and negative attributes, you'll be slightly faster at making that pairing than the reverse. Not because you consciously believe anything negative. You might be a person who genuinely, sincerely holds egalitarian values, but because your unconscious mind has absorbed patterns from the culture you grew up in. Every movie you watched, every news broadcast, every offhand comment, every statistical pattern in who lives where and does what. All of that got fed into your pattern recognition system, whether you wanted it to or not. And the results, when the IAT started generating data from hundreds of thousands of people, were striking. Large majorities of test takers showed implicit biases that didn't match their stated beliefs. People who explicitly rejected prejudice still showed automatic associations that reflected cultural stereotypes. And this wasn't limited to race. The IAT revealed implicit biases related to gender, age, weight, disability, sexuality, essentially any social category where cultural stereotypes exist. Now, The IAT has been controversial, and we should be honest about that. Critics have raised legitimate questions about what exactly it measures, how stable the results are from one testing session to another, and most importantly, how well implicit bias scores predict actual discriminatory behavior. The test-retest. Reliability isn't as strong as you'd want for a diagnostic tool, and the correlation between IAT scores and real-world behavior, while statistically significant, is modest. Some researchers have argued that the IAT captures something more like cultural knowledge. You know the stereotypes because you live in the culture, rather than personal bias that drives your behavior. The debate is ongoing and genuinely unresolved, but here's what matters for our purposes tonight. Whether or not the IAT is the perfect measurement tool, the broader finding it points toward is robust and has been confirmed through many other methods. Your unconscious mind is constantly, automatically categorizing the people you encounter. It's making rapid judgments about trustworthiness, competence, warmth, threat, all based on facial features, skin color, accent, body language, clothing, and 100 other cues. And it's doing all of this in milliseconds, long before your conscious mind has formed a deliberate opinion. Studies using neuroimaging have shown that the amygdala, remember Ledoux's work on the fast fear pathway, responds to faces of unfamiliar racial outgroups more strongly than to in-group faces. And this happens within the first 100 or so milliseconds of seeing the face. That's faster than conscious recognition. That's the low road firing before the high road even gets involved. And this is where the press secretary metaphor we've been carrying through this whole conversation gets really interesting and maybe a little uncomfortable. Because if your unconscious mind is making these snap social judgments and then your conscious mind is constructing justifications for them after the fact, rationalizing a feeling of unease as being about something other than what it's actually about, then you can see how unconscious bias could operate, even in people who genuinely believe they're being fair. The press secretary doesn't know it's spinning. It thinks it's reporting. This connects to a broader movement in psychology and organizational science over the last 20 years or so. The attempt to design systems and environments that account for unconscious bias, rather than just hoping people can think their way out of it. Structured interviews instead of unstructured ones. Blind auditions for orchestras, a practice that, when adopted by major American orchestras, starting in the 1970s and 1980s, significantly increased the proportion of women hired. Standardized evaluation criteria applied before seeing the candidate. The insight behind all of these interventions is the same one that runs through everything we've talked about tonight. You can't simply will your unconscious processes to change. They're not under direct conscious control. But you can change the environment, the structure, the decision architecture, so that unconscious biases have less opportunity to influence outcomes. And that's really the mature understanding of the unconscious mind that's emerged by the early 21st century. It's not Freud's seething cauldron of repressed desires. It's not the behaviorist's empty box that we shouldn't even talk about. It's a vast, sophisticated, largely adaptive processing system that handles most of the cognitive work of being alive. Perception, pattern recognition, skill execution, social judgment, emotional response, creative incubation, and it does most of this work remarkably well. But it has systematic blind spots. It overlearns from certain kinds of data. It's better in some environments than others. It can be trained, but it can also be mistrained. And the relationship between this unconscious system and the thin, bright layer of conscious awareness that sits on top of it is not one of command and control. It's more like a conversation. an ongoing negotiation between a vast intelligence that works in the dark and a smaller, slower, more deliberate intelligence that works in the light. And that negotiation, that dynamic between what you know and what you don't know, shows up in one more place that feels especially relevant right now, given where you are and what you're doing. Because as you're lying there, maybe starting to drift, your brain is getting ready to do something extraordinary, something it does every single night. It's getting ready to dream. And dreaming, it turns out, is one of the most fascinating windows we have into how the unconscious mind actually operates when it's left almost entirely to its own devices. Think about what happens as you fall asleep. Your conscious mind, that press secretary, that thin, bright layer of awareness, gradually steps back. The prefrontal cortex, the region most associated with deliberate reasoning, logical sequencing, self-monitoring, begins to quiet down. Its metabolic activity drops. The executive functions it supports, planning, critical evaluation, the ability to say, wait, that doesn't make sense. Those fade. And as they fade, something else comes forward. The deeper processing systems, the ones that have been running all day beneath your awareness, begin to operate without oversight, without editing, without the press secretary standing at the podium deciding what gets reported and what doesn't. And what emerges is strange and vivid, and often deeply emotional, because you're essentially watching your unconscious mind think out loud. Now, for most of human history, dreams were understood as messages from gods, from ancestors, from the spirit world. The ancient Egyptians had professional dream interpreters as early as 2000 BCE. The Greeks built temples called Asclepiaia, where people would sleep overnight, hoping for healing dreams from the god Asclepius. And Freud, of course, called dreams the royal road to the unconscious. He believed they were disguised wish fulfillments, coded messages from the repressed unconscious that had to be interpreted through free association to reveal their true meaning. His 1900 book, The Interpretation of Dreams, was built entirely on this premise. But here's the thing. Modern neuroscience has given us a very different picture of what's actually happening in the sleeping brain, and it's arguably more interesting than anything Freud imagined, because it's not about hidden messages. It's about maintenance and integration and possibly creativity. The person who changed how we think about sleep and dreaming more than anyone else in the 20th century was probably Eugene Aserinsky, a graduate student at the University of Chicago in the early 1950s. Aserinsky was working in the lab of Nathaniel Kleitman, one of the pioneers of sleep research, and he was given what seemed like a tedious assignment, watching sleeping infants and recording their eye movements. But Aserinsky noticed something peculiar. At regular intervals during sleep, the infants' eyes would begin darting rapidly beneath their closed lids. Fast, jerky movements, almost like they were watching something. He mentioned this to Kleitman, who was skeptical but intrigued enough to suggest they try recording these movements in adults using electrooculography. Basically, sensors placed near the eyes to detect motion. What they found, published in 1953, was that adult sleepers showed the same pattern. Periods of rapid eye movement, REM, occurring in roughly 90-minute cycles throughout the night. And when they woke subjects during these REM periods, the subjects almost always reported vivid narrative dreams. Wake them during non-REM sleep, and dream reports were much rarer and much more fragmentary. This was a genuine discovery. It meant that dreaming wasn't random or continuous. It had a biological rhythm. It was tied to a specific, identifiable brain state. And that brain state, it turns out, is extraordinary. During REM sleep, your brain is almost as metabolically active as when you're awake. In some regions, it's actually more active. The visual cortex lights up, which is why dreams are so intensely visual. The amygdala, Ledoux's fear center, that rapid emotional processing hub, is highly active, which is why dreams are so emotionally charged. The hippocampus, critical for memory, is firing in complex patterns. But the prefrontal cortex, as I mentioned, is largely offline. The dorsolateral prefrontal cortex, in particular, the part most associated with logical reasoning, working memory, and self-reflection, shows dramatically reduced activity. And that combination explains so much about what dreams feel like. You have vivid sensory experience without rational oversight, intense emotion without the ability to step back and evaluate it, narrative flow without logical consistency. Your dreaming brain is generating experience, rich, detailed, emotionally meaningful experience, but without the executive functions that would normally flag contradictions, enforce temporal sequence, or remind you that you can't actually fly. So what is it doing? Why does your brain spend roughly 2 hours every night in this state? This is where it gets really interesting, and where the science connects back to so many of the threads we've been following tonight. One of the most compelling frameworks comes from the work of Matthew Walker, the neuroscientist at UC Berkeley, whose research on sleep has been enormously influential. Walker and others have built a strong case that sleep, and REM sleep in particular, serves several critical functions for the unconscious processing systems we've been talking about all evening. The first is memory consolidation. During sleep, your brain replays and reorganizes the experiences of the day. The hippocampus, which initially encodes new memories in a kind of temporary, fragile form, replays those memories during sleep. And through this replay, the memories are gradually transferred to longer-term storage in the neocortex. This process is sometimes called systems consolidation, and it's been demonstrated in remarkable experiments. Researchers have recorded the firing patterns of neurons in rats' hippocampi while the rats navigate a maze, and then recorded from the same neurons while the rats sleep afterward. The patterns replay. The same sequences of neural firing that occurred during waking experience occur again during sleep, often at compressed speed. The brain is literally practicing, rehearsing, consolidating what it learned. But it's not just replaying, it's reorganizing. And this is where things connect to the default mode network, to incubation, to all of that creative processing we talked about earlier. During sleep, your brain doesn't just strengthen individual memories, it finds connections between them. It integrates new information with existing knowledge structures. It extracts general patterns from specific experiences. There's a beautiful study by Wagner and colleagues, published in Nature in 2004, where subjects were given a mathematical problem that had a hidden shortcut. A pattern that, if you noticed it, would let you solve the problem much faster. After initial training, subjects who slept on it were more than twice as likely to discover the hidden pattern compared to subjects who stayed awake for the same period. Sleep didn't just preserve the memory of the problem, it reorganized the information in a way that made the underlying structure more visible. This is unconscious processing at its most profound. While you sleep, While your conscious mind is completely offline, your brain is doing sophisticated analytical work, finding patterns, building connections, restructuring knowledge. And you wake up, and the answer is just there, and you say you slept on it. And that phrase turns out to be far more literally true than anyone realized until quite recently. The second function, and this one is particularly relevant to our earlier discussion of implicit bias and emotional learning, is emotional processing. Walker's research suggests that REM sleep serves as a kind of overnight therapy. During REM, you re-experience emotional memories, but in a neurochemical environment that's fundamentally different from waking life. Specifically, norepinephrine, the brain's version of adrenaline, the neurochemical most associated with stress and anxiety, is almost completely suppressed during REM sleep. It's one of the only times in your entire life, waking or sleeping, when your brain is essentially norepinephrine-free. So you re-experience the emotional memory, but without the stress chemistry. And Walker's theory is that this allows the brain to reprocess the memory, to retain the informational content, what happened, what you learned, while gradually stripping away the raw emotional charge. You remember the event, but it doesn't sting the same way. The memory is preserved, but defanged. And this, Walker argues, is why sleep deprivation is so consistently linked to emotional dysregulation, anxiety, and depression. Without adequate REM sleep, the brain can't perform this emotional recalibration, and old emotional memories retain their full intensity. Think about what that means in terms of everything we've discussed tonight. The unconscious emotional responses that Ledoux mapped, the fast pathway through the amygdala, the automatic reactions that happen before conscious awareness. Those responses are being calibrated every single night while you sleep. The system is being tuned, updated, adjusted, not by conscious effort, not by willpower, but by an automatic biological process that your brain performs as reliably as breathing. And there's a third function that's worth mentioning, one that connects to the very earliest ideas we talked about tonight, all the way back to Leibniz and his Petit's perceptions. During sleep, your brain is also doing basic housekeeping. The glymphatic system, discovered by Maiken Nedergaard and her team at the University of Rochester, published in 2013, is a waste clearance system that operates primarily during sleep. During waking hours, your brain cells are packed tightly together. During sleep, they shrink slightly, and the spaces between them expand by as much as 60%. Cerebrospinal fluid flows through these expanded channels, flushing out metabolic waste products, including beta amyloid, the protein associated with Alzheimer's disease. Your brain is literally cleaning itself while you sleep. So here you are, lying in the dark, and your brain is about to embark on one of the most complex operations it performs. It's going to consolidate your memories, reorganize your knowledge, process your emotions, clean out metabolic waste, and generate hours of vivid, immersive experience that you may or may not remember in the morning. All of it unconscious, all of it automatic, all of it essential. And that, really, is the deepest lesson of everything we've wandered through tonight. From Leibniz noticing that the roar of the ocean is made of tiny waves you can't individually hear, to Helmholtz realizing that perception is an act of unconscious inference, to Freud's flawed but revolutionary insistence that there's a mind beneath the mind, to the cognitive revolution's discovery that most information processing happens outside awareness, to Libet's startling readiness potentials, to the split-brain patients whose left hemispheres confabulated explanations for decisions they didn't make, to Kahneman's System 1, doing the heavy lifting of daily cognition, to the default mode network quietly working on problems during rest, to expert intuition that's trustworthy only in regular environments, to implicit biases that operate even in people who sincerely reject them. Through all of it, the same picture keeps emerging. You are mostly unconscious. Not in the dramatic Freudian sense of being driven by dark, repressed urges, though emotional learning certainly shapes you in ways you don't fully see, but in the quieter, more pervasive sense that the vast majority of what your brain does, the vast majority of what makes you you, happens beneath the surface of awareness. Your conscious mind is real, and it matters, and it can do things the unconscious can't. It can plan. It can reason abstractly. It can override impulses. It can imagine counterfactuals. But it's a small, bright clearing in a very large forest. And the forest is not hostile. It's not trying to trick you. It's doing an enormous amount of work on your behalf every second of every day. And it's about to do some of its most important work right now as you drift off. The conversation between conscious and unconscious, that ongoing negotiation we talked about, it doesn't stop when you fall asleep. It just changes character. The conscious mind steps back, and the unconscious gets the room to itself for a while, and it uses that time well. It sorts through the day. It makes connections you couldn't see while you were busy thinking. It soothes emotional wounds. It practices skills. It cleans house. So as you feel yourself settling deeper, as your thoughts start to loosen and fragment and drift in directions that don't quite make logical sense, that's not a malfunction. That's the transition. That's your prefrontal cortex dimming its lights, and the deeper systems coming forward to do their work. The same systems that kept your ancestors alive on the savannah, that learned to read faces and predict danger and find patterns in chaos. Those systems are still there, still running, still taking care of things. You don't have to manage this process. You don't have to understand it fully. You just have to let it happen. The way you let your heart beat, the way you let your lungs breathe. The unconscious mind has been doing this for a very long time. It knows what it's doing. And right now, tonight, it's doing it for you.